This first problem is not a proportional problem. It's actually a paired t-test. It's definitely something that could come up on the AP exam. And it is problem 12.9 on page 759. And what you need to know for a paired t-test is that we're finding a difference between two measurements. In this particular problem, get to that real quick. In this particular problem, it's talking about right versus left. And it says the design of controls and instruments affects how easily people can use them. A student project investigates the effects by asking 25 right-handed students to turn a knob with their right hands that moved the indicator by screw action. There were two identical instruments, one with a right-hand thread, the knob turns clockwise, and the other with a left-handed thread, the knob turns counterclockwise. So we've got right versus left. All students, all subjects are right-handed, but what's going on is they've got a knob where one's turning right. This is a right thread. And then another one on another instrument turning left. So they're asking these participants to turn until it stops and time it, and then turn it until it stops and time it. So it says, number A says each of the students used both instruments. Discuss briefly how you would use how you would use randomization arranging the experiment. So you've got 25 people chosen. Let's say you guys are all right-handed and the subjects of my experiment. How am I going to randomize that? How am I going to randomize the experiment? Because there still has to be some randomization involved here. What do you think? Any ideas? Exactly. Yeah, which test they do first, right? How could we choose which test they do first? What would be a good way to choose between two items? Yeah, flip a coin would be great. Let's flip a coin to see which test you do first, right? The right thread or the left thread. So flip a coin. To determine which direction is first. Yeah, there you go. That's randomization. I may not have picked you randomly, but I'm going to test you randomly. Okay? The project designers hope to show that the right-handed people find right-handed threads easier to use. Carry out a significance test at the 5% significance level to investigate this claim. Okay, so B, I'm going to write my null hypothesis and my alternative. In the null, this is a mu problem because we have some data here that we're going to put into our calculator here in just a minute. Mu equals, we want to know if the right-handed people can turn the right-handed thread faster. That's what we think. What would we test that against? That sounds like the alternative. This is a little tricky. we're going to test that against that there's no difference between the right and the left-handed speed. So we're going to say that there's no difference, that mu equals 0, and that the alternative, mu, if it's faster, does that mean that mu is less than 0 or greater than 0? Less than 0. Good. Yeah. Right. Now, what does the 0 come from? Well, it comes from both tests. You take the subject and you say, okay, twist to the right first, and then twist to the left, and we're going to measure the time. And if they're the same, then it's 0. If one's faster, then you get your numbers. So it's a difference between two tests. Let's see, what did they said? Alpha equals 5%. We'll add that. Now, what we have to do is we have to go into our calculators, and we have to put in the data in this table. So I think I actually already have that in one here. But I'm going to recommend that you go ahead and take a couple minutes and put these values into L1, or whatever L you want to put it into, these values into a second. Now you've got your rights and your lefts, and do not sort them. You want, because this value, this 113 and this 137 are from the same subject, it's from the same person, and you want to keep those together. I'll give you guys a couple minutes to get those put in. Clicking on the calculators almost sounds like rain. So when you get that in, what you want to do is you want to go to the top of another list. In my case, it's L3. And we want to find the difference of these. So this is the right-handed, L1 in my case is the right-handed speed, and L2 is the left-handed speed, and we want to know what the difference is. So I'm going to say, go all the way up to the top, L1 minus L2. And if you have a negative number, that means that they were faster turning the right-handed thread. If you have a 0, it means that there was no difference. They turned them both the same speed. And if you have a positive number, they were faster with the left-handed thread. This is the data that we actually want to use to solve the problem. So what we're going to do now is we're going to take and we're going to use our one-var stats on that difference. So calculate one-var stat. In my case, it's L3. I'm guessing you guys are probably the same. And I get X bar is negative 13.32. So I'm going to go back to my workbench here. Write those in. And I need S, or S of x. That is 22 point, I'm going to go 22.9. I think that's plenty accurate enough. And let's make it 9.4. Make it even better. And N is 25. So we're going to standardize x bar minus the claim, mu sub naught, over 22.94 and the square root of 25, which is 5. So that's just negative 13.32. Make sure you put a negative there and not the minus. Calculators don't like the minus. Divided by 22.94. Divide that by the square root of 25, which is just 5. And I get about negative 2.9, 2.90. And that's a t-value, because we had to calculate the standard deviation. So we go to our t-distribution critical values, pull that table out, and I'm going to look at 24, because that's the degrees of freedom for n is 25, and I'm looking for, wait a minute, I'm not going to find any negatives. What do I do? Yeah, you got to look at the positives. So this only looks at the upper tail, but in this problem we've got a lower tail. So we have to basically take that as an absolute value. So it's sort of switching it to the upper, but we know that we're talking about the lower. So I'm going to look over here and I'm looking for 2.9, and it's going to be between 2.797 and 3.081, which gives us some pretty low p-values. I'm going to write those down first. So this is going to be between 2.797 and 3.091. So between p-values of 0.005 and 0.0025. So 0.5% and 1/4% there. So we're way down there. It's somewhere between 0.5 and 1/4%. So do we have significant evidence to reject the null and conclude that the right-handers do turn the right-handed thread faster? Yes, right. So we have significant evidence. To reject the null and conclude the right-handed subjects turned the right thread faster. Okay. Let's see, does that answer? Oh no, we have type 1 and type 2, and a little bit more to go. This is a pretty long, drawn-out problem, this one. So let me be clear here. We're in no risk with that p-value of a type 1 or a type 2 error. But what would that look like in this situation? Type 1 error, I got to move to another page here, sorry. Type 1 error is is going to be, we reject the null, and conclude they're speedier. And conclude write threads are speedier. How about are faster? When what? When they aren't. Yeah, when they're not. When they are actually equal. Okay, they're not faster. They're equal. A type 2 is the opposite of that. We fail to reject. The threads are equal when the write threads are actually faster. Type 1, we reject, and we're wrong. Type 2, we fail to reject, and we're wrong. Okay? We should have rejected. The last part of this problem asks us to look at what if the difference was only 5? I don't know what we're talking about, seconds or something like that. What if the difference was only 5? Would it still be significant? So in this last part, I think it's D, we're going to standardize where the write threads are faster by average, but only by 5 seconds or whatever the time measurement is there. I don't know that it really says. Anyway, so we're going to use the same values for standard deviation, but we're just going to look at that t-value and see if we think it's going to be significant. So that's going to be -5 divided by 22.94, divide that by 5, and I get -1.09. So what we want to look at is, again, an absolute value idea, because you can't find negatives on this table. So we're going to look at 24 for degrees of freedom. And I'm looking for 1.09, which would be somewhere between these two values, the 1.05 and the 1.31. So that puts it somewhere between 5 and 10%. I'm sorry, 15 and 10% on the probability. So the p-value is between 15 and 10%. Would that be significant at alpha is 5%? If the p-value is greater than alpha, is it significant? No, so we would fail to reject on this one. So this is not significant. How about we say not significantly faster? We'll cut it really short here. But if I was answering this for an AP question, it'd be, we do not have significant evidence to conclude that there is a speed difference, so we fail to reject the null, conclude that they're equal. So our average says that it's faster, but is it significantly faster? That's really the question. All right.